Hello everyone, welcome. Can you hear me? Hello. Okay, thank you.
Yes, I can hear you.
Okay, thank you. Just you're waiting 1 minute, then we start.
Hello, everyone.
Yeah. Oh. Just you're waiting 1 minute, then we start. Let me share my screen. So I hope all of you already get the previous materials, mainly practice code and slide. Okay. And I already get all of assignment also I already submitted. Okay. So basically today is our second number class, and let me share my screen. Okay. And mute all of you. So when you have any questions, simply unmute and then ask the question. Okay, let me share my screen. Can you see my screen? Okay, thank you. Okay, thank you. So basically for today's session, we discuss about that introduction to remote sensing, mainly how to use remote sensing. And if you don't have any knowledge about the remote sensing, I hope you can easily learn all of basic things about the remote sensing. And further, we can also apply the Google Earth Engine for filtering and displaying the different types of satellite imagery, mainly Landsat, Sentinel, or MODIS, and how to create the satellite composite or different types of band combination, how to export satellite imagery, and how to export raster data, mainly raster data processing in Google Earth Engine. So kindly mute all of you. Okay, kindly mute. Otherwise, it creates some echo. Okay, okay. And we'll also discuss about the NDVI time series analysis, okay, and also annual image composite. So all of those we try to cover. And for previous class, we also discussed about the two topic is not completed, mainly filtering attribute table. It's not completed. Okay. So we also discuss about also and also how to use the Google Earth Engine with ArcGIS and also QGIS Pro. So this thing we also try to cover for today's session also. Then I hope we can easily get the idea. So okay, so let me open my slide. So I think here all of you already know about the basic concept about the remote sensing. Okay. But I also try to explain all of those from basic. So then I hope it also make you more clear concept about the remote sensing. Okay. So first of all, remote sensing, basically remote sensing is the science and technology of obtaining information about an object, area, or or any phenomenon without making physical contact. Okay, without making physical contact, we just gathering some information. Okay. So it uses different types of sensors. If you don't have any idea about the sensor, so further I also try to explain about the sensor, as well also satellite sensor, aircraft, okay, or drone, UAV, okay, or ground platform to detect and measure the reflect and emitted. Okay, reflect and emitted. If you don't have idea, then I also try to explain all of this. You can easily get the idea. What is the reflected? What is the emitted? Electromagnetic radiation. Okay. So seeing the unseen without physical contact, or without physical tasks. Okay, we simply gathering some information, we obtaining some information about an object, about an area, or any specific properties from the land. We can easily get the information. So remote sensing is the acquisition of information about the Earth's surface by recording and analyzing electromagnetic energy. It can be reflected or emitted from object. Okay. So if you check, this is the one kind of imagery. So human vision and also satellite vision. So human vision is limited. So human vision is only for the limited. We can see only for the limited area for the human vision. But remote sensing allows us to step back and observe the Earth as a deeply interconnected system, capturing physical, chemical, and biological phenomena that are invisible to the naked eye. So this is the one kind of example if you check. So this is the one kind of industrial area. Okay. So northern India. So it's a cement plant in northern India. So for here, if you check, we can easily identify the atmospheric, the different types of gases. So nitrogen dioxide or sulfur dioxide or any other specific gases, we can easily identify using satellite vision. So we can use the satellite sensor and we can easily detect this type of emission. But normally human vision, we cannot observe this type of gases or this type of things we cannot observe. Okay. But when you are using the satellite sensor, we can easily detect the different types of atmospheric pollution. Okay. Infrared reflectors to instantly reveal the invisible nitrogen dioxide emitted from the single cement plant in the North India. We can easily identify the pollution. Okay. And these are basic things about the remote sensing. So remote sensing, it can be two types, passive and active. So passive, if you check, this is the example about the passive. So Landsat, Sentinel, or Modis. So this type of sensor, it's mainly passive. So it measures the natural sunlight. Okay, it measures the natural sunlight reflect of the Earth. Okay, suppose this sunlight, just you can see some different types of surface. Okay, trees, water body, or whatever different types of features, just reflected and recorded by sensor. Okay? Landsat 8 or Sentinel-2. So this type of sensor is recorded, reflected, sunlight reflected of the Earth and relies on the sun as the energy source. So this is the main energy source. Okay. So it relies on the sun energy source. For example, Landsat 8 or Sentinel-2. Okay. But Sentinel-1, if you check, this is the another. Basically, it's a active sensing. So active sensing, it emits own energy. Okay. The sensor emits its own electromagnetic radiation, like microwave, and measure the what bounces back. Okay, example, Sentinel-1 is using a radar to penetrate cloud cover and map structural plot data day or night. We can easily get. So for that Sentinel-1, it's an active sensor. So this active sensor emits its own energy, okay, and measure what bounces back. Okay, so that's the region. There is no connection with the cloud. Okay, there is no connection with the cloud. So for the region, we are also use it for our flood mapping, or also for because flood time there's a lot of cloud in the sky. Okay, so that's the reason when you monitor the flood, we try to use here the Sentinel-1 radar imagery. Okay, radar imagery simply use, and then we can easily get the more better result, okay, for the radar. So these two types, passive and active. Main difference is that so sun energy. Okay, suppose Landsat, Sentinel, Modis. So this type of sensor, it just use the sun energy, but active sensing, it's emitted own energy. Okay, it's not depend on the sun light. So then if you check, this is the human vision. Sunlight consists of radiation across many wavelengths. Human eyes only perceive the small visible spectrum, 400 to 700 nanometers. Okay, so this is the range. Okay, human eyes only perceive the small visible spectrum, mainly 400 to 700 nanometers. Then you also can see the near infrared range, then short wave infrared, thermal, microwave. Okay, so we also use basically this is the RGB, red, green, and blue. This type of range also find out that. But sunlight consists of the radiation across many wavelengths. Okay, sunlight have the lot of wavelengths. We find out that. But in the sunlight, human eyes only perceive the small visible spectrum, 400 to 700 nanometer. But near infrared, we cannot visible. Short wave infrared, thermal, so microwave. So this type of radiation or this type of wavelength, we cannot see our eyes. Okay? Our eyes only perceive the small portion, only for visible, 400 to 700 nanometer. Okay, but when we are using the remote sensing, we can easily identify different types of wavelength. We can easily get near infrared, short wave infrared, and thermal, and also microwave. So this type of wavelength we can easily identify by our satellite sensor. Okay, satellite sensor, it receives this type of information, near infrared, short wave infrared, thermal, microwave, and also visible is also available. Okay, it also available this level. You can get it. So Earth's atmosphere absorbs the specific wavelength like harmful UV. Satellite place their sensor and especially within the atmospheric window, and the wavelengths that successfully pass through the atmosphere to the ground and bounces back into space. Okay. And there's a lot of things also happen in this section also. So different types of scattering. Okay. Also find out that reflected or absorbed or transmitted. Okay, so this type of energy, interaction with the Earth's surface, incoming energy. This incoming energy from the sun, it can be reflected or absorbed or transmitted. Okay, this everything also. Suppose healthy vegetation. Healthy vegetation, it's high near infrared reflectance. Water, low reflectance. Air soil, moderate reflectance. So no very high visible reflectance. Okay. So then if you check this type of Landsat 8 spectral matrix, so we are using different types of bands. Okay, different types of bands. Suppose coastal or ultra blue band, okay, short visible, then water absorb. So you also try to read this type of slide, I'll send you that. So it will give you some theoretical part. What types of band absorb, what types of feature. Okay. So water absorbs most light. This band catches the varying the shades of the blue. And also vegetation, you can see vegetation is the heavily reflect by near infrared band. Okay, and water absorb it completely. Then you can see the concrete and bare earth heavily reflect this band, IR band or short wave infrared band. Okay, so turn the exactly what atmosphere absorb the light. Okay, so I also send you this. You also try to read, then you can get the more better idea. And we also use different types of sensor. Okay, top atmosphere, surface reflectance, raw radiance. Okay, so this type of satellite means we can easily identify. So surface reflectance, then top of atmosphere reflectance, then raw image or raw radiance. We also use this type of things. And this is the fourth dimension of the resolution. So spatial resolution is very important for the satellite imagery. Okay, spatial resolution basically it's indicating about the pixel size. Okay, pixel size. How effectively the sensor separate physical object. Okay, measure as a ground sample distance. Suppose 30 centimeter or 30 meter. Suppose Landsat is the 30 meter. Okay, Sentinel-2 is the 10 meter. Okay, 10 meter pixel size. So one pixel it's cover on the ground 30 meter. Okay, suppose one pixel for the Landsat it cover on the ground 30 meter. Okay, 30 into 30. Okay, 30 into 30. 900 square kilometer area is covered on the ground. So this is the special pixel size or special resolution. It's indicating about that pixel size on the ground. Suppose this type of pixel. So it's a 1 pixel or grid. So this grid 30 meters. It means that it's covered the 30 meters in the ground. Okay, this pixel covered the 30 meters. Suppose this pixel is the 500 meter. Okay, 500 meter. This pixel size. So it means that it covered on the ground 500 into 500 square kilometer area it's covered. Okay. Suppose this pixel is the 10 meter. So this pixel 10 meter is it means that it's covered on the ground 10 into 10. Okay, 100 square kilometer area. 1 pixel or one grid, it's covered the 100 square kilometer area on the ground. Okay, so it's called the spatial resolution. Then if you check the temporal resolution, it's mainly revisit. Revisit. Suppose in Dhaka city, I have an image, Landsat 2. In suppose 1st January, I have a one image. So second image, when I can get for the same area. Okay. So how frequently a satellite captured the exact the same coordinate. Suppose Dhaka city boundary, I have an image in 1st January. So second image I can get when. So it's indicating about the temporal or revisit time for the same location, same coordinate. So for the revisit time, mainly we find out it's 3 hours to every 16 days. So Landsat is for 16 days. Okay, Landsat revisit time is the 16 days. Sentinel-2 is the 5 days. Okay, 5 days. 5 days. We find out that. So you also get all of information when you work with our satellite imagery. Then you can check all of information, spatial resolution, temporal resolution. Temporal mainly revisit time. Okay, spatial basically pixel size on the ground. 10-meter pixel size means that 10 meter on the ground. Okay. So then temporal, it revisit. Then if you say the spectral basically it's the count number, band number, band number. Suppose how many bands on your image. Suppose multispectral, 3 to 11 bands. Okay, multispectral, Landsat, Sentinel-2, Sentinel-1, it's a multispectral. Okay, it's called the, mainly we find out the multispectral 3 to 11 bands. Landsat, Sentinel, this type of image, if you check, they only have 3 to 12 bands. Okay, but as well as we also have the another technique for the hyperspectral. It's very, very important when you work with the more details mapping. Suppose mineral exploration mapping, we also use the hyperspectral. So hyperspectrals have the lot of bands, hundreds of extremely narrow bands. We find out that. So this type of bands, it's mainly storing the different types of wavelength. Okay, wavelength. So when I use the hyperspectral, then I have lot of bands. So then I can easily get the lot of information. Okay, it gives me the more precise information about the ground. Okay, but multispectral it's a 3 to 11 bands. Okay, Landsat, Sentinel. So it's called the multispectral. And hyperspectral, it can be neon satellite imagery, neon or Aster. Aster is one kind of hyperspectral imagery. So multispectral only for the 3 to 11 and hyperspectral hundreds of the over the hundreds. Okay, or extremely narrow bands. We have the more details documentation. Then radiometric, it's indicating about that how many levels of brightness sensor can distinguish. Okay, how many levels of brightness sensor can distinguish. So early 1997 satellite were 4-bit. 4-bit basically 0 to 63 level. But modern sensor are 12-bit. Okay, 12 bits, it's more than 4,000 levels, separating virtually identical object. Okay, so it indicating about the bit. So previous we are use the 4-bit. So now modern sensor have the 12-bit. 4-bit this range 0 to 63 level, and 12-bit it's indicating about the more than 4,000 levels, separating virtually identical object. Okay, so this type of basic things about all of image we find out. Okay, Landsat, Sentinel, MODIS, or any satellite, every satellite image we have this type of information. Different. Suppose Landsat 30 meter pixel resolution. Landsat is the 30 meter. Then Sentinel-2 is the 10 meter. MODIS have different types of resolution. 250 meter, 500 meter, 1000 meter. Okay, different types of resolution. Temporal, it can be different types of. For the different satellite, have the different temporal revisit time. Landsat suppose 16 days. Sentinel-2 for the 5 days. Okay, MODIS have the different. MODIS have the daily or 8 days. So different types of temporal resolution for the MODIS also have. Spectral, basically band number. Okay. Then radiometrics, it's a brightness, level of brightness a sensor can distinguish. Okay. So 4-bit, now 12-bit also available for the modern sensor also use. So now it's very important. So basically, if you check the, it's a geometry observation. Okay, SWOT as the versus details. Okay, so high coverage, low detailed, and high detail, low coverage. Suppose you want to work with big study area. Okay, very big study area. Suppose whole continent you want to work. So it's a very high study area. So then we find out the low detail. Okay, low detail. So it has some because spatial resolution is a low. Okay, but when you are using here the high coverage area, we find out the low detail because it's a spatial resolution is the low. Okay, but when you work with the high detail, low coverage, suppose for the specific only for the small study area, I want to use, then I can get the more information. I can get the more detailed information because this resolution is very high. Okay, those 10-meter pixel, it's very we find out the more detailed information when I use the 10 meter. Suppose you are using at the 500 meter. 500 meter is not give you the more detailed information. So basically, it's indicating about the large area or also a small study area, as well as suppose 10-meter resolution, 500-meter resolution. So we can easily get the idea. 500 meter, it's not give you the more detailed information, but 10 meter, it's give you the more detailed information. Okay, because 10 meter is the low resolution, low pixel value is the low. When pixel value is low, it's indicating about the high resolution. And when pixel value is the high, pixel area is high, it indicating about the low resolution. Okay. So then you also use, you can see that the other sensor. Okay. So this type of SMAP, it's one kind of sensor. It's a 30-kilometer pixel. Okay. Pixel size of 30 kilometer. Okay. It's a micro regional, measure the microwave emission from the earth and to track the soil moisture anomalies and also drought condition. Okay. SMAP, it's one kind of sensor. Then chirps, this is another sensor. It's a 6 kilometer pixel, very high pixel size. Okay, so it's a combined satellite and ground data to map precipitation and rainfall variation. We also use this sensor. Then birds, it's a 750-meter pixel. It's highly sensitive to low light and tracking the nighttime radiance and rural electrification and urban growth. We also monitor using this sensor. Then MODIS, it's a 250-meter pixel. It's a neighborhood level. It's captured the entire world every single day. Okay, Terra and Upa, both for rapid art monitoring. Okay, Landsat 8, it's a street level, basically 16-day revisit time for highly accurate and multispectral and land use tracking. And Sentinel 2, it's a 10-meter pixel, the highest resolution public domain data. So Sentinel 2, it's a freely available and it's very high resolution. Okay, 10-meter. So basically, in the remote sensing, we can get the high resolution freely. Globally, it's available. Freely and globally available 10-meter. It's a highest resolution. Okay. So this is the highest resolution public domain data. Not only for that, if you want, you can also buy some satellite data. Suppose Maxer, you can also buy, as well as also export satellite data. So it's a one kind of commercial data. Okay. So commercial data we can also use and also use it. So then it will be 3 meter or 0.5 meter, 0.6 meter. So this type of commercial satellite images we can also buy and we can also use. But publicly available for the globally highest resolution is Sentinel-2. Okay, it's really publicly available. Okay, publicly available Sentinel-2 is the highest resolution publicly available for the globally. Okay, but when you need the more high, suppose 6-meter resolution you need or 5-meter, so then we need to buy the commercial satellite imagery and then use it. Otherwise, highest resolution data publicly available for Sentinel-2. Okay. So this is the concept about that. Okay, we also discuss about the sometime, then you can get the idea. So when I talk about the band combination. Okay, anyone in question, you can ask me about that. Any slide, any confusion, you can ask me.
Yeah. So thank you for your explanation. And based on these images, which one is more accurate?
Okay, kindly raise your voice and again, yeah, I cannot hear. Please.
Yeah, based on these images, which one is it's more accurate?
So basically, accurate, it's depend on your research objective. Okay, because Sentinel-2. So in this case, Sentinel-2, it's a more accurate because it's a high resolution. Okay, but when you work with historical data analysis, okay, our Sentinel-2 is available only for in year of 2017 or 2015, 2017 or 2015 it's available. But when you work with for the past time, suppose in 1979 or 1980, 1990, then you must use at the Landsat 8. Okay, because it's available very past time. Okay, 1990 or 1973. I think 1973 we find out the Landsat 8 data. But when you work with normal condition for present time, only for the present time, then Sentinel-2 is the more better because it's a 10 meter. Okay, 10 meter we can get the data, and 10 meter give you the more detailed information. This accuracy is very high, but when you work with the historical data analysis, very past time, then Landsat is more better. Okay, for the historical data analysis, historical, very, very past time. Okay, also use it. Okay, so let me try to explain after some time, then you can get the more better idea how to work with different types of visualization. So before that, okay, let me open my code editor. So previous class I already discussed about that how to work with how to import the shapefile. Okay, how to import the shapefile. We already discussed about that. So now we also discussed about the some basic things about the GIS. Okay, GIS basically Geographic Information System, and basically GIS have the two types of data, basic two types. One data is called that vector, another is called the raster. The raster. So all of raster data it's including as a satellite imagery. Okay, all of raster data. Suppose Landsat, Sentinel, MODIS. So all are the including in the satellite imagery. Okay, raster data. Raster data have the satellite imagery. Okay, so you can see SMAP, charts, birds, MODIS, Landsat, Sentinel-2, or any aerial photography or any drone image. All are the considered as a raster. Raster have the grid. Raster have the grid or cell. So this type of grid or cell we find out in the raster. Okay, raster have the grid, only grid or cell. Okay, this it's called the cell or grid. So it's called the raster. But vector, it's just it can be point, line, or polygon. Very simply, point, line, and polygon. We find out the point, line, or polygon. Suppose I represent a city as a point. I can represent the river as a line. I can represent a boundary. So it's a polygon. Okay, point, line, and polygon. It represents the different types of feature. Okay, exploring. Okay, let me zoom it. So mainly GIS, there are the two types of data. One data, it's called the raster. Another data, okay, just let me add the comment, then it will be more better. Okay. So one is the raster, another is for it's called the vector. Okay, vector. So raster and vector. So raster, what is the raster? So raster data have the grid or cell. Okay, grid or cell, and every grid and every cell have one or more unique values. Okay, it give you the values. Every cell have the value, value. We find out the value. So it's called the raster, grid or cell. And vector, it can be point, line, or polygon, Okay, point, line, or polygon. Suppose I want to represent the city. I just use the point. I represent suppose road, center of the road. So then I simply use the line. I represent suppose the building area. So just I create the polygon. So this is the basic concept of the GIS and remote sensing. We find out the two types data, raster and vector. In Google Earth Engine, we find out the total 5 types of data. Okay, 5 types of data. So one, it's called the geometry. Okay, geometry, it's one kind of data type in Google Earth Engine. So geometry, it's indicating about that fundamental of vector data. Okay, vector data. Okay, so it's a geometry. So geometry is one kind of data type. Then another data type, it's called the feature. Okay, feature. What is the feature? When a geometry, I just add the information, then it called the feature. Suppose, suppose I have a point, I have a geometry. Suppose I have a geometry. Suppose geometry mainly suppose point, line, polygon. I have a point, suppose latitude 89.876, look like that. And longitude, suppose I have 90.675, this type of longitude. So I have latitude and longitude. This is the geometry. It's a point. It's a point. When I add the information, this point is for Dhaka. Okay. So it's an attribute. It's an information. So when I add the information in my geometry, then it's called the feature. Okay. Suppose I have a geometry without information. I have a point, but this point, what is for? What the information about the point? What is the attribute for this point? I don't know. So when I add the information, this point is for Dhaka. This point, this Dhaka, suppose I add the many information. So for this point, I add different types of information. Suppose Dhaka, population, all of those I can add for this. It's called the feature. So when I add the information in my geometry, then it convert as a feature. Okay. Then another data type, it's called the feature collection. Feature collection. Feature collection. So what is the feature collection? Set of feature. Suppose when I add the more feature, suppose this type of feature, more than one. Suppose two feature, make a feature collection. Three features, make a feature collection. So more than one feature, create a feature collection. Okay, any question? Okay. Then another data type, it's called the image. Image. So what is the image? Image is the fundamental data type of raster. Okay, raster. It's the image data type. And finally, image collection. Image collection. What is the image collection? It's a series of images, okay, or a stack of images. So these 5 types of data we always find in Google Earth Engine. Okay, so Google Earth Engine, it's work with 5 types data: geometry, feature, feature collection, image, and image collection. Okay, always. And if you check, click on the so if you check the documentation tab and search here, if you check, it's a feature. Okay, so feature. So this is the function. When I click, I can get all of function. You can say probably a lot of function. So this type of function I can use only for feature data type. This is the function for feature collection. So when I click, it gives me the all of function. And this type of function I can use only for feature collection data type. Not only for the geometry. So all of function I can use only for the geometry. Okay, only for the geometry data type. Then if you check image, so all of function I can use only for the image data type. And finally, image collection. So all of image I can simply use only for image collection. Okay, so data type is very important. Every data we need to use the different types of function. So geometry, we use the geometry function. Okay, you can see we can get all of function in here. So geometry, this is the geometry. You can see different types of function only for the geometry. Geometry, multi-point, multi-polygon, geometry point. Suppose I want to use it, click on here. So if you check how to use the function, if I show you that, suppose just click on here. So this is the function geometry.point. I need to define the coordinate and projection. Okay, and it constructs an geometry. describing a point. So if you check here, it's a default EPGS. Okay, 4326 is default, it's not a problem. And if you check the what is argument, it returns the geometry point. Okay, so how I can use it? Suppose I want to create a point. Just I copy the function. Just I copy. And if you check the argument section, this is the coordinates, and that another is that projection. And if you check, projection is the optional. Okay, it's optional. So when you check the argument, we find out the two types. One type is optional, another type is not the optional. Okay. So you have to check all of argument. It's optional or not optional. So if the optional, if you ignore it, suppose I don't use it, there is no problem because it's optional. Okay. So if you want, you just use only for this coordinate. There is no problem. Okay. So because it's optional. So every argument you also check which one is optional, which one is not optional. So if it's optional, then we can easily find out the optional. Okay, it's optional. It's totally if I ignore this argument, there is no problem. But I cannot ignore this argument because it's not the optional. You must use it. Okay. So all function have this type of argument. We find out that optional or not optional, you can easily get. So you also try to check this type of argument, not only for this function, any function. Okay, we can easily check it. Okay. So now I want to create the geometry. Okay, geometry. So how I can create the geometry? So how I can create the geometry? So for that, I just copy this one and I want to use it. Okay, just I paste here. Okay. Just I paste here. Why it not showing? I think some server problem because all functions show as a gold, green, or purple color. Okay. Okay, let me open the new code editor. I think some networking issue. That's why it's create this type of problem. And let me paste here this function. Just paste it. Oh my god, why it's not showing? Just a minute. Okay. Okay, but it was purple color. Okay, so now it show this type of color. I don't know why. Okay, let's go try to write the code. So I just apply here coordinate. Suppose I put the longitude and latitude value. Suppose I want to focus 90, 90.414125. Okay, this is the longitude value, and put the latitude 23.8181. Okay, I think some problem on my side, so that's why it's not working. Networking issue, but it show the purple color always. Okay, so we find out. Suppose I just create the longitude and latitude, and these things I store it in a variable. So before the variable name, we simply use here the var keyword. Okay, then put the variable name. You can put any name. I put the name suppose point. So now if I just print, suppose if I print and run it, so you can see it show the geometry. Okay, and if you check this geometry, it's a point. Type is the point. Okay, so this geometry it can be different type. Okay, geometry it can be different type. Suppose one type, it's called the point is one type. Okay, point is one type. Second type, it's a multi-point. Multi-point. So this is another type. Third type, it's called the line string. Line string. Fourth, it's called the multi-line string. Multi-line string. Fifth, it's called which one? It's called polygon. Okay, polygon. Okay, then we also said that multi-polygon, and finally it's called the rectangle. Correct. So geometry can be this type of 7 types of geometry find out in Google Earth Engine. Okay, point, multi-point, line string, multi-line string, polygon, multi-polygon, and rectangle. So you can see here when I just use it, EE geometry point, I define my coordinate. Then it show the when I print, it show me the type is the point. Type is the point. So you also try for multi-point later because I also give some assignment. So you try to create the multi-point. You try line string. You try to create multi-string, polygon, okay, multi-polygon, rectangle. Okay, so you try to create this type of feature. Rectangle. And how we create, if you check, suppose that give me some idea how to create. So if you check the geometry, click on here. So you can see the line string. Okay, this is the line string function. Okay, just I click. So then if you check, just click on here. So if you just put the coordinate, then it create the line string. Okay, suppose just put the coordinate. Suppose you put the one coordinate value and put the another coordinate value. Okay, then it just create the line string between the two coordinate. Two coordinate make the one line, or you can use the more coordinate. Okay, you try to use this type of function. It also practice. Okay, it also help you to get the more knowledge. You can see the multi-line string, multi-point, multi-polygon. So you also try to do this type of things later after the class. Okay, you try. So we find out this type of geometry. Basically, it's called the types of geometry. Geometry we are using in point, multi-point, line string, multi-line string, polygon, multi-polygon, and rectangle. So if you check, this is the point, okay, and it show the type is it's a point, okay, it's a geometry. So this geometry, how I can convert into feature? Okay, for the feature, I already say about that. When I add the information, suppose for this coordinate, I just add the information. Okay, then it convert as a feature. Okay, so let's see how I can convert the feature. This geometry, how I can convert into feature. So feature is a geometry plus attribute. Okay, so I also write some comment. It will also help you. So feature equal, we can say feature is a geometry class attribute. Okay, attributes. We can add the more information. Attributes. Okay, so now how I can add the information. So for that, if you want, you can also take a variable. I put the variable name, suppose Dhaka. I put the Dhaka. And then you can put it in as a variable. So now I just apply a function. If you check the function for the feature, this is the geometry, and then this is a feature. Click on here to the feature. Click in the first function, you can see ee.feature. Okay, you can see this argument is the geometry. Okay, and then properties. So if you check, we find out that geometry, it's a geometry argument. You must use optional. It's a property is the optional, but if you want, you can also use it. No problem. So just I copy this function. Okay, and then paste here. And what is the geometry? In this case, I use this coordinate. Okay, I already stored it in the point. Just I call the point. Just I paste here. Okay, this is my geometry. Okay, point is stored my geometry. Okay, point geometry. So now I add the properties. Properties basically information. So for the how I can add the properties, if you check the argument again. So properties, a dictionary of meta properties. So previous class I already discussed about that, how to define a dictionary. Anyone can guess it, or anyone remember how to define a dictionary? Which symbol we need to use? Again, dictionary, what's the structure or what the symbol we need to use? We already discussed about the dictionary.
Yes.
The list.
In a dictionary, we have two aspects.
Yeah.
We have the key value and the key
part.
Yeah. It's separated by column. the keyword and key values,
Yes, yes, yes,
and
yes.
then use a curly bracket.
Yeah, curly brackets. Thank you, thank you, thank you, thank you. So for that, just I simply apply, because you can see it already show about that it's a this argument is that it's a dictionary of metadata properties. So dictionary. So for the dictionary, what I need the curly bracket, and I need to define keyword and key value. Keyword and key value. So I put here the keyword. Suppose you can put any. I put the name. Suppose country. Country. This is the keyword. I put the key value. Suppose Bangladesh. Bangladesh. So it's a one kind of property. I add the more. I add the more. Suppose I put that another keyword city, and I put the city is suppose Dhaka. You can put any information. It's an attribute. I want to add suppose I add suppose year. So year it's a keyword. I put the key value 2026. Okay. So now this type of attributes I just simply connect with my geometry. So that's why it's called the feature. Okay. So now let me print. Suppose just I print the data. Print the data. And then if you check, it show the data type is feature. Okay. Data type is the feature. If you check the type is the feature. Okay. And what the properties, if you check it, this is the property. City is the Dhaka, country is the Bangladesh, here is the, we can add the more. Okay. So it's basically it's a attribute table. Okay. In our shapefile, basically previous class I discussed about that how to work with shapefile. So shapefile have a attribute table. This attribute table call as the properties. Okay. Suppose you can check the any shapefile have the attribute table. So this attribute table call as the properties. We find out that this type of information for this coordinate. Okay. So this is the feature. This is the feature. So now, suppose from these properties, I want to check a specific value. Suppose I want to check for city value or any specific keyword. When I put the specific keyword, it give me the only for this value. Mainly it's called the getting the properties. Okay. So how I can do it? So for that, if you want just print, suppose I want to print my, suppose this one, Dhaka. And from this Dhaka, I want to check the city. Okay. Just put here the dot get function keyword and call your keyword. Suppose I just check the city. Just I copy the city and now run the code. So now if you check, it show the computer object Dhaka. Okay. So this is the one kind of process to mainly getting the properties. Okay, getting the properties. Suppose I want to check the year. So now run the code. So now we can easily get the what is the year. So here show the now y. Okay, I put the it's a uppercase. Okay, y is the uppercase, but I put the lowercase y, so that's why it creates. So if I run the code, it show the year. So this is the process. Okay, for a specific properties, how I can get. Not only for that, suppose in this I want to add the another properties. So how I can add in this in here? How I can add the another properties? So for that, if you want, you can also write in here. Suppose I just write in here another properties and do it. But I want to create the another variable and then storing. So adding the new property. Okay, adding the new property. So how I can add the new property? So for that, if you want, you can just take a variable. Suppose I put the same variable Dhaka, and I call my this one Dhaka, okay, which is already have the feature. I want to set the new property, and this new property, suppose I want to add suppose food keyword and add the another food is the rice. So now let's check what happened if I print the Dhaka. Now run the code. So now check the final output. It added the new another property. This is food is the rice. Okay. Suppose I already have the this type of feature, but I want to set the new feature with the same variable. Okay, then I just call this variable Dhaka and set which I want to need. Just I add. Okay, then it will be added in here. Okay. I also get because this type of things we also use a lot of time. Okay, for different types of analysis. So it's called the feature. Okay, it's called the feature. So now we talk about the feature collection. So what is the feature collection? You already know. Feature collection is the set of features. Okay, suppose more than one feature. Okay, suppose I just create another feature. Okay, let me show you that. Suppose I put another. Suppose take a variable. Suppose city one. I put here suppose ee dot feature. Okay, feature. So in this case, if you want, you can see here. So this print, I stored this information. Okay, and this point, it stored this information. But that I call the point and paste in here. Okay, but if you want, you can directly, so just directly copy all of those, and then paste here. Okay, there is no problem. Okay, so ee dot feature, then define your geometry as a point. But previous time, this line I store it in a variable. Okay, further I call the variable. But now I simply use the same full line of code. Okay, if you want, you can also store it in a variable and then call the variable same. It's the same. Okay, but in this time I am not storing this line in a variable. So then I put the suppose one information. Just I add the property. For the property, use the curly bracket. I put the keyword suppose city and put the city is for suppose Dhaka. So this is the one feature I simply add. I add another. It's a geometry. One feature because I add the information. Okay, so then it converts as a feature. It's a one feature. I take the another feature. Suppose take a variable. Suppose city two. So same line of code I simply write. Just I copy. Just copy and paste here. Okay, I simply change the coordinate. Suppose I put the coordinate for 91. .83 and 22, suppose 2236. Okay, and I put the city name, another city name. Suppose I put it say Chattogram. Okay, same. Just I okay. Then I simply take the another city. Just I copy. Okay, another feature I just simply create. Take a variable. Suppose this is the city 3, and I put the coordinate. Suppose I put the coordinate is 89.55 and 22 point suppose 85. Okay, so then I put the city name. Suppose this is the Ulna. Okay, so I put this type of city name and put the coordinate. So city 1 to 3 just I created. So now I create the feature collection. So how I can make the feature collection? Feature collection mainly set of feature. Okay, so these 3 city I just combine. So how I can combine? So take a variable, suppose cities, and apply ee dot feature collection. A feature collection. We simply apply. And if you check this function, feature collection, what is that? Feature collection, where is it? It's the feature collection. If you check the feature collection, it shows the RGS column. Feature collection can be constructed from the following argument. You can see a string assumed to be the name of the collection, a single geometry, single feature, list of feature. So in this time, list of feature. So list of feature, a list of feature, because you can see it's a list. So for the list, what's the condition? How to make a list? Anyone can guess it? How to make a list? Because we already discussed about the list.
For a list, use a square bracket.
Yeah, square bracket. So we simply create the function e.feature collection and then make the square bracket, okay, for the creating the list. So now we simply call the city one. It's my one item on the list. Okay, then comma, then city two. So this is the another list. I paste here. Then call the city three. So this is another list, another item of the list. Okay. So now further, if I print, suppose if I print the cities, so then it work as the feature collection. Mainly we combine. So now run the code. So if you check it to the feature collection, this one, click, then you can get the type is the feature collection. Okay. And if you check the feature, so they are the total 3 feature. Okay, 3 list 0, 1, 2, 3. When I click, then I can get all of information about this. Okay, for the first city is Dhaka, second city is Chattogram, final and final last stage is the Khulna. Okay, so we combine. Okay, so I hope you can get the idea for geometry, feature, and feature collection. Any question you can ask me. Okay, I hope there is no question. So now this type of city or this type of feature, I want to visualize as a layer. I want to visualize as a layer on my map. Okay, so it create the point. It create the some point. Okay, for this. So how I can add? So how I can add the map layer? Okay, how I can add the layer? All of cities. So if you check here, just simply search here layer. Layer. So if you check the map.add layer, so this is the function. So map.add layer, it's a function, and you can see that the total 5 arguments. And if you check the optional, okay, it's optional. If I not use, there is no problem. Okay, if I am not use this name, there is no problem. It's optional. If you check Sean, it's optional. So opacity optional. So if I ignore all of optional, there is no problem. But one argument you must use, e object. Okay, e object you must use. Otherwise, this function cannot work because you must use it. So map.add layer, when I use this function, what it give me? It give me a layer. Okay, UI mainly user interface. User interface map layer. So it create the user interface map layer. And this one argument is important, but others it's not important. It's optional. Okay, so I want to use. And if you check the what is the e object, so you can see e object. It can be feature. Okay, it can be collection, basically feature collection, image collection. Then it can be image. It can be raw map ID. Okay, so I can easily display the feature. I can easily display the feature collection or image collection. So just I copy all of those. Just I copy and then paste here. Then, so all are the optional. All are the optional. Just I may remove. Okay, only it's very important e object. So I just keep only for this argument. And then make a dictionary, curly bracket start, and I put the keyword and key value. So this is the keyword e object. Okay, so this key value I want to display, suppose this feature collection cities. Just I copy and paste here. So now run the code. If you check, it add a layer. Okay, it adding a layer, this type of layer, but not focusing on my given study area. Okay, it focus on the United States, but I want to use the another function which help me to focus on my given study area. So for that, simply search here center. So if you check, where is the center? Map center. Simply search at the map center. centered. You can see the map.centered object. Okay, this function map.centered object. So this function centered the view on a given object. Okay, so if you check here, argument is the object. Okay, it can be geometry or element or on an object to the center on a geometry or image feature. Okay, and zoom basically it indicating about the zoom level 0 to 24 range. So just I use it, and you can see zoom is the optional. On complete is optional. If you check, it's optional. If I ignore this both, there is no problem. But this object is very important. You must use it. So just I copy and paste here. So then I make a dictionary. So curly bracket start and curly bracket int. So first of all, just I remove this type of, it's not need now. Just I remove object. I want my object is cities. This feature. So now if I run the code, if you check, it directly focus on my given study area. Okay, it's directly focus. It directly focus on my given study area. But I need suppose more zoom. I need the more zoom. So how I can do it? For the more zoom, I need another argument zoom. Just I call the zoom. And make the keyword and key value. Zoom, I put suppose zoom is the 10. So now run the code. So now it will be more zoom. You can see. It creates the more zoom on my given study area. So you can see this is my 1 point. This is the another point. So it creates this type of point. Look like that. Okay. So it creates this type of point. Look like that. So these two functions is very important. Map.addLayer and map.center object. Center object, it focus on given study area. And map.addLayer, it's add the layer. It's add the layer for feature collection, okay, or geometry. We can easily add. Suppose if you check, if I just add here map.addLayer, add layer, and then I just call the point. Or if you want, you can simply put here dictionary and put ee object. This is my keyword, just a copy. And then call point, this point, and run the code. So it creates the single, only for single geometry display. You can see it creates the two layer because I use the two time. Okay, two time because map.add layer in this code I use the two time. So that's why it show the two layer. You can check now this layer display only for the single geometry. Okay, so you can easily display any feature, single feature easily, or you can easily display the feature collection, mainly combine and display. Okay, so now let's take the practical example. So let me open the another code. In Google Earth Engine, we find out some data set. Okay, data set. Suppose country boundary, a shapefile, or city boundary shapefile. We also find out this type of data. Okay, it's available. So for that, if I just simply search here US simply search, then it give me the list. You can see this one, last one, large scale national country boundary polygon. Just take click. So if you check, this is the one kind of data set. This data set provide you international country boundary polygon. Okay, international country boundary polygon. It's provided the United States Office of the Geographers. And if you check this data set, it provides all of international country boundary polygon. Okay, this is the data set. So if you check, this is the snippet ID. Okay, snippet ID. This is a snippet ID. And if you check this is the ee.feature collection. It's a function. So feature collection, it means that this data set including more than one feature, lot of feature. So that's why it shows the feature collection. So just I import. Okay, so when I import, you can see it show this type of line. So anyone can tell me what's the variable name in this line of the code. In this line, what's the variable name? Okay, let me show you from here. So now you can easily get the idea. What's the variable name?
It is called table.
Yeah,
Table.
Yes. Thank you. So table is the variable name. It's the default variable name. Okay. Then if you check, this is the function e.feature collection, and this is the directory. Okay, directory or snippet ID. Mainly all data are stored in the Google Earth Engine data catalog. So in the data catalog, this is the directory. When I go to this directory, I find out my data. So this is the directory or cloud server directory. Okay. And it's a feature collection because this data, it's a more than one feature because all countries information. So that's why it shows the feature collection. And table, it's a variable name. We can put any variable. That is no problem. Okay. So this table, it's including all of international country boundary polygon. So if I print, suppose I want to print this information, just I print the table. I want to print the table, suppose size. So this size indicating about the how many countries information is stored in this table. So size, it's computing how many items in one collection. Okay, let me check it. So it including total 312 countries information. Okay, well, 312 countries polygon. Okay, this data set including. But this feature collection, how many features? This feature collection total 312 features. Okay, so now I want to print suppose table. From this table, I want to check the first feature. Okay, first feature I want to check it. Just I run it. Mainly first element. So you can see it give me the feature, first feature. I want to check all of information. You can see the properties. So you can see. So this type of property, I already discussed about the properties. Okay, so mainly when when I connect geometry with property, it's called the feature. Okay, so you can see we can filter using the country code, country name, and world region. So first feature, it shows the country code is the CD, country name is the Chad, world region is Africa. It's really attributable information. So now I want to filter. Suppose I want to filter for my specific country. So how I can filter? So for that, just take a variable. You can put variable. I put the suppose RY. I just call this table. Okay, just call this table. And I want to filter. So this table including total 312 features. So now I want to filter a specific one. So Art Engine filter dot equal. So what's equal what? I choose the one argument, suppose country name or country NA. And I put the country name, suppose Bangladesh. So now what happened? So now in this data set table, where total 312, but I want to filter, how I can filter? Where country name equal Bangladesh. So now this variable is stored the Bangladesh feature. So let me check it, what happened for Bangladesh feature. Just I print the RY and run the code. So it display the Bangladesh one, only one feature you can see. Only one feature. Let me check it. These properties, you can see these properties, it show you the all of information about the basically abbreviation Bengal, country code BG, country name Bangladesh, and world region South Asia, East Asia. Okay, so we can get now Bangladesh feature. I want to display as a map layer. So how I can add? We already know about that map dot add layer. Okay, and then I got, you can see all of argument. So it's optional, just I remove. And further, I just make the keyword and key value. Just I put the keyword and put the key value is the ROI and close the bracket. Now run the code. It's at the layer, but not focus on my given study area. But I want to focus on my given study area. Just use here map dot center object. Object is if you check all of argument. So just I remove one complete and zoom, or you can make just I put here the keyword and key value and object. It's my which area I want to focus. I want to focus on my Bangladesh boundary or Bangladesh feature. It is stored the ROI. Just I call the ROI and put the zoom level is 10 and run the code. So now it directly focus on my given study area of Bangladesh. Okay, so this is the Bangladesh country boundary polygon. Okay, so any country, you can simply put the country name, then we can easily get that. Suppose Saudi Arabia, just now run the code. So now it directly focus on the Saudi Arabia country boundary polygon.
Can I ask a question here?
Please.
Actually, if I have a shapefile in my local machine, okay, I don't want to use this from the link, the one that is large scale international boundaries. If I have my own shapefile, like if it is for security or something like that, how I can import that one? I mean,
I
how
think
I
these
can
things
use
I
that
already covered
shapefile.
for the previous class. Previous class we discussed about that how to import the shapefile. Okay, so just click on here and
Yes,
go to the
yes, yes.
shapefile. So I'll show you that. So after importing, how to show the
Okay.
layer, I will show you that. No problem. I will show you that. No problem. Okay. Any other question?
Sorry, sir, but if we need a city of the country, how can we add into the map add layer
Which one?
or map center object? If we need a city in the country.
City. Okay, let me show you that. Let me show you that. You can get the idea. No problem. So this is the country level. Okay, this data set provide only for country level boundary, but I need the okay, so just simply search here FAO. So this one you can see, I think last one. Okay, let me, okay, this one. Okay, second level, you can see the second level. So this is the second level information. So this is the data set. Just import this data set. So same, you can see it show the table. So let me check how many information in this table. Just print and call the table and use the size function. It's computing how many cities information available for the whole. You can get the total 38,258 cities. Okay, in this collection have. I want to check suppose first one. Just print and check the table. Just take over the table and check the first item. Just put here the first. And the first feature, we check it. So now if you check here, we can get this table. You can see this table. You can see. So first feature it show the which one. So administrative name 1, administrative name 2. I don't know what is the name about the Cocos. So this is the country name Cocos. Country code 56. AU territory. You can show this type of information. Okay. So administrative not abbreviation. Okay. So this type of we find out. Okay. So now what happened? We can do for that. So for that, if you want, okay, let me show you another trick. Suppose let me check it for a specific country. Suppose in the Saudi Arabia, I want to check. So for that, if you want, we can simply take a marker. So just I just need suppose Riyadh boundary. So just I click on this, click on here. So it's a create a marker or geometry. So just I call my table. It show the geometry for this geometry, and I take a variable. Suppose I put the variable same geometry, no problem. and then I call my same geometry, and apply the filter bounds function. Filter bounds with geometry. Okay. So this is the filter bounds function. It's mainly identify in this area, all of geometry. Sorry, it will be table. A table. So in this table, lot of data. Okay, for the whole world, but I need the data only for the geometry. Okay, this table is stored the all of data, total 38,258. But I need the data only for this area. So for that, I simply take my geometry and I filter bounds with my geometry. Okay, so you can put any variable. I put suppose I put the ROI, it will be better. So I take the new variable ROI, I call my table, it's my data set, it including 38,258 feature globally. Globally, it's available. But I don't need for the whole world. I need it only for the specific area of interest. So for that, I just take a geometry and filter bounds with the geometry. So then I check the ROI and also check the first ROI. Now let's see what I'm going to check. So you can see only for the one, because I filter only for the one. And further, if you check the information, click on here and click on the properties. Then let's check all of information about the properties. So it show, you can see the country code name is the Saudi Arabia. Okay. Administrative level 1 name is Riyadh. But you can see administrative level 2, it's not available. So it's one kind of problem. You can see this it's not available. We can access only for the administrative 1 in Riyadh. But when you work with administrative level 2, then you need to upload the data. It can work. So now let me display suppose this one for the Riyadh I want to display. So how we can do it? So let me show you that. So for that, just take a variable. Suppose I put the variable name is any name. I put the name suppose John. Okay. So I just call this table. I just call this table and then filter. How I can filter Earth engine dot filter dot equal what's equal what. So I simply take the information administrative level 1 is the Riyadh, this one, and I put the value is the Riyadh, same name. Okay, if you mistake any spelling, then it will be not work. Try to use the same name, Riyadh. So now if I just add the layer, okay, so in this time if you check, I put the another way. If just put the value, not keyword and key value, just I put the value John. It also works, there is no problem. Okay, just put only value, just write on the code. So now it show the layer of Riyadh boundary. So you find out this is the Riyadh boundary. Okay, find out that. So we find out that this type of things. Okay, so now suppose I remove the geometry from here. Suppose I need the information for any other study area. Suppose let me check for suppose Bangladesh, because it's available for all division, all district is available in the Google Earth engine. A level 1, 2 is available. So for that, I simply suppose take a new geometry, and I need suppose for the Jamalpur, just I choose it. So now for this boundary, I need suppose all of information. So how we can check it? Just I comment, and further I check the information. Then I try to use the information. So if you check it, so it show the feature, and further if you check the property, the country name is the Bangladesh. Then it show the, I think it's a previous data. So that's why division name show as the Dhaka. Okay, but now division is the Maimanshing. Okay, it's a previous at Dhaka. Okay, then you can see district name is the Jamalpur. Okay, we find out that. So I can easily use the administrative level 2 and use the Jamalpur. So how we can use it? Just I copy. And change it. And also put the name Jamalpur. Just I copy and paste here. And further, I want to just display the layer and run the code. So now I find out the Jamalpur district boundary. It's a district boundary. Only administrative level 2. So it's very important when you work with your study area. First of all, you try to check the information, because some area is not available. Some countries are not available. Level 2 is not available for some country. Okay, so for that, what we can do, suppose I don't have this Google Earth engine don't have this type of data. So for that, we simply import our data. So let me show you that. I already discussed about that, how to import the data, shapefile data in our asset tab. Okay, let me show you that. So if you want, you can simply, okay, so previous class I already discussed about that, how to import the shapefile. Click on the asset tab and find out the shapefile for 41 base. Okay, I already uploaded this one. So if you check, just we can get all of information. You basically can see the features, attribute table, all of those you can easily get. So if you check the features, so you can see it show you that all of district name, name 2, name 1. Okay. So name 1, name 2, you can get all of district name. Okay. So just I want to use it. So how again? Just import. So you can see it's a import as a feature collection. Okay. It means that more than one features. So same. So how I can filter? So take a variable, suppose ROI, then call the table, then filter, Earth engine dot filter dot equal. So what's equal what? Go to your attribute table. So if you check the features, so I simply call my column name 2. It's my column name, district or sub district or any other column. I just choose the name 2. Okay, and then I simply put my district name. Suppose Dhaka. Okay, so now Dhaka boundary is stored in this variable ROI. I want to add the layer of this boundary ROI and also focus map.center object. Okay, without keyword and key value, I just put only value. ROI. I put the zoom level, suppose 10. I put only value without dictionary. This is the another way to fill up the argument. Okay, so now we can get this area. Okay, any other question you can ask me, please. Any question? Okay, I hope there is no question. Okay, you can get all of those more better. So if there is no shapefile, you try to manage the shapefile, and further you can also upload in your asset and further also display. Okay. We are just make a break for 10 minutes. After that, we'll come back again and continue the class.
If there is no filter, I have a shapefile. I just want to upload the complete shapefile.
Yes.
Just there is no need to filter it, right? You don't need to use the filter column.
Directly you just copy the table or copy your variable and then use here. Directly copy and use here. So let me show you that. Suppose.
Okay.
So let me show you that. Suppose just I open my code. Suppose I have a Dhaka only for one shapefile for one feature for Dhaka. Suppose here I already uploaded this one. This one Dhaka only for the Dhaka. Just it's a Dhaka. Table is the default. I put here just ROI. And now I want to display. Suppose map.add layer of ROI and also focus. So map.center object the object name is the ROI. Zoom level suppose 10 and run the code. So now it will work. Okay? No problem. We can get only for the one feature.
Yeah.
Okay, so we are just make a break for 10 minutes, then we'll continue the class. Okay, welcome back. Can you hear me? Hello. Hello, can you hear me?
Yes.
Okay, so let's continue the class. Okay, so now I hope already get all of you what how to use geometry, feature collection, or boundary. So now we talk about the another. It's called the image collection. Image collection. So image collection mainly set of images, or series of images. Okay, or a stack of images. So lens set is one kind of image collection. And for the image collection, you use the function. If you check ee.image collection, ee.image collection. So this is the function ee.image collection. So you simply use it. If you check it, ee.image collection can be construct from the following argument. It can be string, okay, name of the collection, list of images, okay, or anything that can be used to construct an image, single image, compute object. So basically, if you check all of data, mainly image collection, so just click on here and click on the browse data catalog. So then it will be open our Google Earth Engine data catalog. Okay, it's a Google Earth Engine data catalog. In the Google Earth Engine data catalog, if you check, you can see the Landsat image collection, Modis, Sentinel. Okay, so I check on the Landsat. Just click on the Landsat. So now here we find out that all of collection, you can see the Landsat. Okay, Landsat 9. Okay, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So all of image collection you can easily find out in the Landsat. So from here, if you check the Landsat 9, it's available at this time. Okay, Landsat 8 is available between this time. Landsat 7, okay, we check all of time period. If you check, you can get it all of time period. So all are the image collection. Landsat 9 is the image collection. Landsat 8 is the image collection. Landsat 7 is the image collection. Sentinel, if you click on the Sentinel, then you can get all of Sentinel image collection. If you check the Sentinel 1, it's a SAR image collection, radar image. Okay. It's a Sentinel 2 multispectral instrument. Okay. Then you can see the Sentinel 5P tropospheric monitoring instrument. Sentinel 3 ocean color. Okay. So all are the image collection. Notice, this is another image collection. Different types of image collection we have. So now this type of image collection, how to use? Suppose Landsat. So all are the image collection, and when you work any image collection, just apply the same procedure all time. Okay, just apply the same procedure all time. So Landsat, Sentinel, Modis all are the image collection. Okay, so in this time we talk about the image collection. And when you work with any image collection, just apply the same process all time. So just like click on the Landsat 9, and you can see the surface reflectance, top of atmosphere reflectance, and raw image. Okay, so surface reflectance, top of atmosphere reflectance, and if you check the Landsat 9, it is a collection to atmospherically corrected surface reflectance. Okay, it already atmospherically correction already done these images. Also, you can see it's a two calibrated top of atmosphere reflectance. Okay, so just I click anyone, suppose surface reflectance, then I can get all of information about this image collection. So you can see we find out that dataset availability time. It's available between this time. Okay, and its provider USGS, and Earth is a snippet, mainly ID, snippet ID. And if you check, this is the revisit, mainly temporal. It's a 16 days revisit time. Okay. Then if you check the pixel size, 30 meters, it means that 1 pixel, 30 meter ground. Okay, 30 into 30, mainly 900 square kilometer area cover. 1 pixel. 1 pixel covered this area on the ground. So this is the image properties. You can get a lot of image properties. cloud cover land, then also collection category, data source, different types of properties. This is the bands. You can see the coastal aerosol band, then blue band, okay, then red band, green band, and all of bands are in here. So this image collection, how I can work. So first of all, just copy the snippet ID and paste on your code editor. Okay. So now I just take a variable. So I put the variable name, suppose collection, then equal. So this image collection, I store it in this variable. So now let me check how many images are available in this collection. Just I copy and use the size function. Okay, we already use the size function. Basically, image collection, feature collection, we can easily use the size function. It computing how many features or how image is available in this collection. Just run the code. So now it's computing the number for the whole world. Whole world between this time 2021 to 2026, this time, how many images are available? We'll find out that. So we find out the large number of image collection, okay, for this whole world between this time. But I don't need for the whole world. I need suppose only for the Dhaka city boundary. Okay. And I already imported Dhaka city boundary as a ROI. Okay. So how I can filter only for my boundary study boundary area. So further is simply use another function. If you want, you can also use here just dot and put here the function. It's called the filter bounds function. Okay, we already used the function previous time. Suppose this is the large number of image collection. It's available for the whole world. But I don't need for the whole world. I need the image collection only for the specific boundary. Okay? I need the image. So further, I simply use the filter bounds function and define my geometry. Okay, define my geometry. Okay, in this time my geometry, this is my geometry. Okay, Dhaka city. And the geometry is stored in the ROI. Just I call the ROI and paste here. Okay. So now further I want to check how many images are available in Dhaka city boundary. Okay, let's run the code again. And if you check here I use the two function in one variable. Okay, two function in one variable. The first function is the e.image collection. It's mainly stored the all of images in the world between the time period to full time period 2021 to present time. And then I simply use the filter bounds function. It mainly intersecting only all of those images which are available in the Dhaka city region. We find out the 184 image collection. Okay, because you can see because I use the same collection. Just take all the collection after using the filter bounds function. I find out that 184. It means that for my study area in the Dhaka city, it's available 184 image collection between this time period, whole time period. Okay. But I don't need all images. I need only for a specific images. Suppose less than 1% cloud cover image I need. Okay. Or any low cloud cover image I need. So how I can filter? So from 184 images, I choose only all of those images which are the less than 1% cloud cover. So how I can filter? Just use here the dot filter metadata. And if you check for filter metadata, if you want, you can also search all of function under the image collection. If you check, let me show you that image collection. Just I find out that one function I already used the filter bounds. If you check filter bounds function, argument is the geometry. Shortcut to a filter a collection by intersection with a geometry. Okay. And it find out the collection. Okay. So after filtering, I find out the collection 184. So now I want to use the filter metadata. So if you check name, operator, and value. So what is the name? Name mainly property name. Which property you want to filter? I want to filter cloud cover. Then operator. Operator, it can be less than, greater than, not less than, not greater than, this type of things, operator. And value is the number. Okay. So I call the image property name from here. Suppose you can check the image properties, just a click. I just call the cloud cover. I choose the cloud cover less than 1%. So just I put at the cloud cover. And it's a string. String you must use at the quotation, otherwise it creates some problem. So let me add the quotation. Then we just put here the operator. Operator is the less than. And I need the image less than 1% cloud cover. 1. So now let me check how many images is available in the Dhaka city boundary less than 1% cloud cover. Just run the code. 35 images. Okay, 35 image collection is available in the Dhaka city boundary less than 1% cloud cover. And what is the time range between this time? Sorry. Between this time, 2021 to 2000, this time. But I don't need whole time. I need suppose a specific season, a specific month, or a specific year between this time. Okay. So how I can do it? How I can filter the time? So for that, simply use the filter date function. Okay. Then put your time. Suppose 2026 January 1st January from, and put the in date 2026. Suppose 0 January, February, April, May. Suppose May. May 30. So I need the image between this time. So let me check how many images I find out that run it. So it shows the only about 2 images. Okay. So less than 1% cloud cover, only for the 2 images are available between this time for the Dhaka city boundary. Okay. If I increase, suppose less than 5% cloud cover, let's check how many images we find out that on this time. 5 images. Okay. So we always try to keep lower cloud cover. Okay, we always try to keep the low cloud cover, because low cloud cover image, it neat and clean. So we find out the all of things neat and clean. So we always try less than 1%. Suppose any region less than 1% is not available, then we try to put here the 2%, 3%, 4%, just I increased the number if there is no available. So first we try less than 1%. Okay, to get the neat and clean satellite imagery. So in this case, I find out the 2 imagery. If you check, you find out the 2 imagery. And this 2 imagery is stored in this variable. So you can see how I can filter. So first time, I find out the large number of image collection. Then I filter for my study area. Then I filter for my specific cloud cover, less than 1%. Then I filter a specific time period. And finally, I find out the 2 images. It's a less than 1% cloud cover. This 2 images is available between this time, and this 2 images is cover my study area, Dhaka city boundary. It's available. The filter bounds, it's indicating where do you need the image. Then it's indicating about that how. Suppose less than 1% cloud cover image. How? And finally, it's a when. Time. Okay, I need the image between this time. Okay. So where, how, and when. Just to use these 3 conditions, where, how, and when, and we can easily filter any image collection. Not only for that. Landsat, Sentinel, MODIS, surface reflectance, topward, atmosphere reflectance, Sentinel 5P, any other. So you also try others also. Okay. Sentinel 2 you also try. I also give some assignment. You also try to do this type of things. Okay. So any image collection you
Hello, hi. Can I ask,
please.
can I ask one question?
Please.
Here, the cloud cover, I did not get this cloud cover point actually here. Less than 1, what does it indicate actually?
Less than 1% cloud cover. Okay. Suppose I have total 800 images. So this 800 images including lot of cloudy. Suppose 0 to 1 to 100% cloud is available. But I choose only for less than 1% cloud. All of images I choose.
Okay. Okay. Okay.
Okay.
Okay. And filter date, like if with this filter date from 1st January 2026 to 30 May 2026, like here also there will be multiple images of that, let's say Saudi Arabia, and it has let's say 50 to 100 images, something like that. But again, here if you want to use only for the month of May, which with less cloud cover over there.
Yeah, you
In
try
that case,
less cloud cover month, it will be better. No problem. Yeah. Or any season, so you can put the seasonal time. Suppose this is the summer season, okay, or any season you can also apply, no problem.
even for some, okay, let me just guide one. Okay.
So anytime you can simply put in here, okay, then it'll be okay, no problem. Or any month, sometimes monthly image is not available. Suppose it's a Landsat 8 is the 16 days revisit, okay, so 2 months we find out the image, okay, 2 months we find out the image. Or when you work with suppose seasonal, okay, suppose 5 month or 6 month or 4 month, then it will be okay, no problem, because 16 days the revisit time. Okay. Okay. So these three things we simply apply and filter our image collection, and it provides the two images, okay, less than 1% cloud cover. I want to get all of information about the image. So how I can get the information? Just I call the print and call the collection and run the code. So now it gives me the two image information. Just click on here. If you check the feature, that's the two images. First image, second image. So just click on here, click on the properties. So now I can get all of information. You can see this is the 0.91 cloud cover. Tire is the 1. And if you check that this is the acquisition time, okay, or capturing time, data capturing time, you find out that. So all of information easily get from here. And if you check, this is the ID of the image, first image. If you check same, suppose this is the second image, this is the ID for the second image, and this is the all of properties about the second image. We find out that. Okay. So now suppose I want to use this first image. So how I can take? You can see type is the image. Type is the image. Type is the image. So how I can get only for the first image, or how I can get only for the second image? So just copy the ID of the image. Okay. So let me copy this ID. Okay, this ID just I copy. This is the ID, just I copy. And further take a variable. Suppose image 1 equal. I put suppose ee.image and paste the ID. So when you represent the single image, then you simply use an ee.image function. Okay. So now I want to add the layer of the image. So just map.add layer and call the image 1 and run the code. So now this image will be added in our code, in our layer. So you can see it show this type of image. But if you check, this image have a problem. You can check. This tiles is not fully fill up my area. Some part is missing. You can see this part is missing. So now how I can solve this problem? Because this tiles is capturing only for this part. You can see this whole part it captured. But some part is still missing. So for that, let me check for another image what happened for that. Just I click this image 1 and copy this ID of this image, then check what happened. Just I copy.
Okay.
And then check it what's happened for that. Just on the code.
So within that period, there are only two images, right?
For my study area, it's different on your study area.
Yes, for your study area, between January to May, we have only two images for that study area. It
for
may
my
be
study.
4, 5 for other study.
So
Yeah,
other
maybe like
area,
if
it
I
will be
select my
different.
yes, maybe 4 or 5 as
Yeah, any
it is
number.
available.
It can be any number. It can be any number. No
Oh.
problem. So for my study area, now I have only 2 images between this time less than 1% cloud cover. And if you check, the second image is fully cover my study area. Okay, you can see this is my study area, and this is the image. It fully overlay. So now I simply use the clip function dot clip with my study area ROI. Okay, this is my geometry ROI. So now if I run the code, you can see, then I can get the image only for my region of interest of Dhaka city area. So it look like that. Okay. So now we talk about the band combination. Okay. So now let's back to the slide. So in the band combination, we are use the 3 bands make one combination. Okay, 3 bands make one combination. Okay, kindly mute the mic. So when you have the questions, just simply open, and then otherwise it create the echo. Okay, so this band combination, 3 bands make one combination. Suppose RGB. RGB, it's a red, green, and blue band. Create this type of natural. It's a natural what human eye can see. Okay, this type of naturally. So it's called the RGB band combination. So computers natively displayed red, green, and blue channel. By feeding the satellites corresponding red, green, and blue bands into this channel, we create the human vision. Okay, human eyes. Okay, normally see this type of feature. So when you visit the aeroplane, or then you can easily get this type of things. Okay, this type of view. It's a human vision. But we can also use the another. Suppose it's called the false color composite. You can see. Okay, so it's including by mapping invisible band into visible channel. Okay, invisible band. So normally, near infrared band, when sunlight comes, there's a lot of wavelength. We cannot see all of those. We can get only for red, green, and blue. We can easily human I can see. But near infrared, microwave, then short wave infrared one. So this type of wavelength we cannot directly see in our eyes. Cannot see this type of wavelength. By mapping the invisible band into visible channel, we highlight the unseen traits. If we map the near infrared band to the computer's red channel, so healthy vegetation show as a bright red. So basically, when I just use the FCC, basically it's a near infrared red and blue. When I put this type of combination, then we can easily get the invisible bands into visible channel. We can find out, and we can easily get the all of unseen traits. Okay, all of unseen things we can easily visualize. Okay, so there are a lot of uses for the different sector band combination or band ratio. Basically, this type of band combination and band ratio were used to identify different types of feature from satellite. Okay, let me show you the example. Suppose now I want to apply the band combination in this satellite imagery. Suppose RGB or red, green, and blue. So now I just click on here. So I set the channel red, green, and blue. I keep stressing as 98%, or you can put any stressing level. So I put suppose 98%. It's a not high, not low. Okay, middle. Just I put here, then apply. So now if you check, it show this type of natural color. Okay, naturally we find out this type of hue. It's one kind of band combination. Naturally we find out that. Okay, we find out because this type of imagery. So this satellite imagery, we find out this type of view. So it show the vegetation as a green color, build up, this show this type of color. Okay, you can see this type of, we find out that. So it's a normally human vision see. Okay, naturally, this type of things. So just I import this one. Just you can see import button. When I click on the import, you can see it added the new line of code in here. Just I copy the variable name. And this visualization I want to set with this layer. So how I can set just copy this visualization parameter and paste after the image one. Just type paste. Okay. So now this visualization is set it with my layer. And you can see it show the layer one, layer 2. I want to put the layer name. So I put the layer name, suppose, you can put any name. I put the name, suppose, RGB. Okay, you can put any name. Just run the code. So now if you check it, it set it the color, which I set, as well as also set the RGB layer name. Okay, two layer, one layer for boundary, second layer is for RGB. Okay. So now I want to add the another layer for FCC or false color composite. Only invisible band add with the visible band. Okay, so let me show you that. So invisible band, basically near infrared. Near infrared is the B5, is the near infrared band. It's invisible. So normally we cannot see. Okay, on our eyes we cannot visible this type of band or this type of wavelength we cannot see normally. But this wavelength, when I connect with the visible band, suppose near infrared, red is the visible, red and blue, it's also visible. So invisible band, I simply connect with visible band. And further, I create the band combination. This I keep 98% same and then apply. So now all of vegetation show as a red color. Okay, vegetation area show as a red color. Water body show as a black color or dark color. This type of black color or dark color. We can say the water body. We find out the red color is the vegetation. It's a vegetation. This type of red color. Okay, we find out this type of gray color. It's a barren land. We find out that this type of gray color. And you can see this type of water body show as a black color or dark color. We find out that. Okay, so this is the invisible band. I simply connect with visible band. Then we find out this type of band combination. Just the import. Okay, you can see when I click on the import, a new line of code will be added. So I want to create the another layer and display this map. So how I can do it? Same. Just I copy the same line of code because I use the same image but different visualization. So just I call the vis param2. This it extracted this visualization parameter and paste here. And then I put the layer name. I can put any name. So I put the name is the FCC, false color composite. Just I run the code. So now this tag also added. Okay, you can see. So let's create the two layer, RGB and FCC for the same image. So if you check, you find out that this is the FCC. Okay, we simply connect the visible band, invisible band with our visible band. Okay, so FCC and CB. This is the RGB. This is the FCC. So you can see now we can get all of vegetation more detailed and all of water body we can easily identify as a black color and dark color. Okay, we can get it. And vegetation show as a red color. So not only for that, we can also add another one. Just I click on here. So I just call the another invisible band. This is short wave infrared 1. It's a B6. Short wave infrared 1. Then I put the another invisible, suppose near infrared. And I put the blue, visible. Just a stressing 98% and then apply. So now I find out this type of band combination. So it gives me the more detailed information also, you can see. So now I can see all of vegetation show as a green color. Okay, it provides the more detailed information. Okay, so green color as a vegetation. We find out the bare land, this type of gray color, I think, gray color. Okay, and if you check this type of place is the vegetation, green color. Okay, find out that. I want to import, just like click import. You can see it added the another visualization parameter. And for the same way, just I copy the same image, but I want to apply the different visualization parameter. So not only for that, there are a lot of pen combination is available in remote sensing. So if you check some basic books about the remote sensing, so I also have some PDF book. If you want, you can simply, okay, let me show you that how to get. Just go to this website. and click on, you can see the some resources, click on the resources, and then you can simply download, you can see I added some PDF book. So this is a learn data visualization with Python, remote sensing and GIS integration. Okay, so this one you try to open and also download it, and further you also try to read. Okay, then you can easily get the lot of basic idea about the remote sensing and GIS integration. Okay, so you have to get the idea from here. So I put the another name. Suppose I put the name is I put name suppose vegetation. You can put any other name. Just run the code. So now it also select this type of band combination also in here. So you can see. When I add the different types of band combination, it's helped me to identify or detect the different types of feature on the surface. Okay. Okay. Do you have any question? You can ask me.
Validation means you have calculated NDVI or just you have named that one?
Oh, later we try to discuss about the later this type of indices and DVI. Just I display the image with different types of band combination.
Okay.
So it's cover all of those. Okay, so every topic will be covered step by step. So I can enjoy all of this class and also learn a lot of things. Okay, so I try to start from the basic to advanced. Okay, so all of those we try to explore. So this is the image. We find out that with different types of band combination. So further class, you also try to add the more other band combination. You try to search some paper or some book to identify different types of band combination. Okay, and also try to display. So now we discuss about that. So if you check, we find out the small state area, Dhaka city, and we can get this type of image. But I need the image, suppose whole country boundary of Bangladesh. Okay, suppose this one, Bangladesh boundary, where suppose Saudi Arab boundary. Suppose I need the whole boundary, I need the satellite image. So how I can do it? So for that, one tiles or one image is not enough for the big study area. Okay, big study area is not enough for the one image. So in this case, you can see here I just use only for the one image. One image, I simply use the one image. But when you work with the big study area, suppose whole country boundary of Saudi Arabia, whole country boundary of Bangladesh, or whole continent of Africa or South Asia, or any big study area, then one tiles is not enough. One tiles is not enough for creating the image for the whole boundary. So for that, what can I do? So for that, we discuss about the image composite. Image composite. Okay, image composite. So what is the image composite? So an image composite is a single image created by combining multiple images from an image collection over a specific time period. Okay, so image composite is a single image created by combining multiple images. Okay, and there's a lot of uses. Suppose let me copy the same line of code because I already discussed. Just take copy, and then I want to use it in my code. Where I okay this one. Just I paste. So I simply ROI because I put the ROI. So I just filter for ROI. Cloud cover less than I choose. Filter date, suppose this one. So let me check how many collection. Just I run. Okay. How many collection you have for the whole Saudi Arab boundary between this time. We find out the 558 image collection. Okay. For the whole area of interest in Saudi Arab. Okay. If you want, you can just check all of image one by one. Just I print and check suppose collection. Then it give me the all of in details information about the every single image. We find out that. Okay, just click on here. So you can see it show you the all of information. Okay, every single image information. Just a click and then you can just copy the ID. I want to display the image. Just a copy. The same procedure, just apply and then you can display the image. Suppose take a variable. Suppose image and then image and paste the ID. Then I can easily display the image. So let me just add the layer and display the image for the single image. Just call the image and run the code. So now if you check another layer for this image, but this single image, if you try all of image one by one, you don't find any image which is fully covered with your whole study area of zero. Okay, if you check, it just cover only this part. Okay, only this part it's covered. Okay, so even if you try for another image, same procedure, just take the another image, take the another image. So it's covered the other part, but not fill up the whole boundary. Just I copy and change it. It fill up the another part of the study area of a specific small study area, not big. If you check, so here this image we find out that if you check this image is find out here. This part you can see. A very small part you can see, only cover this part. Okay, very little you can see this one.
If I want to, let's say for the month of April, I want whole Saudi Arabia dataset with cloud cover less than 1%, and in a single, in one image composite. So that is possible.
Yeah, let me finish. Then you can ask the question. Okay, I will just cover the topic. Okay. So when okay, so sometime I also give the question after topic complete the topic. Then you can ask me the question because I just show you the example and then I will step by step. Okay. So when I just complete the class, you can get all of idea. Okay. So let me finish.
Yeah, I mean, okay.
Yeah. So when I just finish the topic, then you can all of those you can easily get the idea. No problem. Okay. No problem. So we find out that when you try, it's not possible. Single image is not possible to cover for the whole study area. Yes, single image is not possible. So then we are need to use the composite topic process. So what is the composite? Composite, it's create the single image by combining multiple images. So I have total how many images in this case? If you check how many images, total 558 images. Okay, so just I combine all of images and create a single image. Okay, then it will cover whole Saudi Arabia boundary. So let me show you that how it will be work. So just I take a variable. Suppose for the final image, and I call the collection and apply the median composite. So now let's check if I just add the layer, map.add layer, and call the final image. So now this final image, it creates the single image, okay, single median composite image, and it fully covered our whole study area of Saudi Arabia. It's fully covered. So further is simply apply the clip function. Okay, after creating the median composite, then apply the dot clip function. Clip with ROI. Okay, so it create the single image by combining total 558 images. Okay, and there's a lot of benefit to use the median composite. So median composite or image composite, it help you to remove the cloud and cloud shadow, reduce the atmospheric noise, create the seasonal annual image. So seasonal, any season, rainy season, summer season, you can easily create the composite. improve the image quality, and also it's best for prepare the data for land use land cover classification, perform the change detection and time series analysis. Okay. So further, I want to add the band combination to visualize more better. Click on here. And I want to create, suppose, near infrared. Then, or I put, suppose, short wave infrared. Then near infrared. And put the blue. I give it to 90%. And further, just apply. So then just import and then call the vision parameter and paste after the object. And I put the layer name, suppose image. You can put any name. Image composite. So we find out this type of imagery if you check for the whole Saudi Arabia boundary. So further, we are just use the image and compute the different types of remote sensing analysis to identify land use, land cover, vegetation, or whatever you need. We can easily detect all of those. So we find out if you check this type of green color, just zoom more. It can be choroplane or vegetation. You find out that. And see. This type of green color, it's a choroplane area. You find out that. Or what are
When you are doing image composition,
yeah.
There is some. Can you zoom out, please? There is a line over here. What does that line indicates? That is the mosaic, or is there no overlap there? Like you see here, the rectangle. I mean the plus symbol with black, light black color over here.
This
Here,
type of
what
line.
does this? Yes. No. Here. You see black line. Black line. Yeah, that one.
It's not a problem. It's not a
Yeah.
problem. It's not a problem. When you export the image, this line will be not have any problem. So basically, it's show
Yeah,
the
there is no gap, right?
no, there is no gaps. You can see when I just move, there is no. It's not a gap. It's not a gap. You can see
Okay.
now there is no. But when I just you can see sometime when I just move, you can see when I just move the map, then it will be show. Okay, you can see now not showing. It's just because it's a big steady area. So that's why you can see. Now there is no line you can see. But you can see when I move, you can see this you can now can see. You can see. This part you can see. Yeah? But when I move, there is no line. So but when you export, there is no line. It's not a problem. But sometimes also get some lot of line, lot of scattering line or lot of gap. Okay, then we also handle this type of things using the different types of remote sensing technique. But now this image is neat and clean, not any types of problem. You can see this line is also available also in here. You can see this one. You can see this line also in here. Right? But there is no map. So this is the image we find out that. Okay, it's called the median composite image. Okay. So you also try. So now you also try to with Sentinel imagery, mainly Sentinel 2. You also try. Okay. And also try for Modis. Okay. I also give some homework also. So now we'll also try for Sentinel 2 and Modis for filtering, displaying the map. So now we discuss about the QGIS software. Okay, how to install or how to implement for Google Earth Engine. Okay, so for that, just you simply search here. QGIS I already downloaded. Just I open.
For ArcGIS Pro also we are going to set up, right?
Yeah. So ArcGIS Pro, I also show you that how to work with ArcGIS Pro for Google Earth Engine. So this is a QGIS, it's open source. So easily installing, and it's freely available. So in the QGIS, just open and go to the plugins, manage and install plugins. Then simply search here Google Earth Engine. Okay, Google, this one, the Google Earth Engine. Simply search. My God, it's a problem. Module not found error. Module PKJ resources. Problem. Let me find out. Let me uninstall this software. There was just uninstall the plugin and then install again. Yes, please. Any question? Yeah.
So the new version of QGIS, there have no plugin with Google Earth Engine, because I will make it in old version, but the new version no have a plugin.
Okay, new version
I
of Google
think.
Earth, QGIS needs not have the Google Earth Engine plugin. Yeah.
I think, yeah.
Okay, so let me try for that. Okay, let me just simply search here or click on the all and search here Google Earth Engine. So Google Earth Engine, this one. Okay, integrate QGIS with Google Earth Engine. Okay, let me install again. It could not load plugin. Module not found error. No module name PKJ resources. Okay, it show about the Python version 3.1.12. Users 3.4411. Right.
Sir, can I have a question?
Please.
Can we use GIS Pro instead of QGIS?
Yeah, we can also use the RGS Pro also, no problem. Okay, it's also work, no problem.
So there is no difference between the two. If we use QGIS or we use the GIS Pro.
So both of things I'll try to show you that, no problem. You can use anyone, no problem. But in our class, I try to show you that QGIS and also show you that RGS Pro. Okay.
Thank you very much, sir.
Okay. I think it shows some problem for my Python environment. Okay, so that's why it's not loading now for the Google Earth Engine plugin. So plugin, let me check the Python console. If I import, suppose, for Earth Engine, okay. It shows I'm not responding. Okay, that's fine. It's hang freezing. Okay, it's working. Import the Earth Engine successfully import. So EE dot authenticate. Okay. Okay, true. There is no problem. Then EE dot initialize. Initialize with cloud project. project. So I mentioned my project EE. It show okay. Did you mean initialized? Okay.
Sir, I think the I you must write in capital.
Now let me check. But where is the tab for Google Earth Engine? So quick OSM, where is it? Plugin. I already select this one. Okay, so let me try to fix this problem. I think when I fix the problem for plugin, e.plugin, so I hope it will be loaded. Okay. So then I will easily show you that. Or just a minute, let me share my another screen. Okay. No. Okay, let me show. Okay, so I'll try to show you the next class, inshallah. Problem how to solve. But it also is still running, no problem. Plugin is available. Okay. Google Earth Engine, integrate the QGIS Google Earth Engine. So then we can easily work. Okay, so next class, inshallah, we discuss about that. How to integrate the QGIS and also ArcGIS for installing the system and then work with that. Okay. So now to talk about the problem solving class. Okay, so previous class, anyone any problem, simply ask me the question. I can also share the screen if you have any problem, please. Anyone any problem for the previous class, mainly first class? Anyone any problem? You can ask me, please. Or any problem for the assignment, you can also ask me about that. And we discuss about that. Okay, I hope there is no question. Okay. So I will send you all of materials for today's session as soon as possible. And tomorrow, inshallah, at the same time, we will meet and further about the third day's topic. Okay. Okay, so you can also take ask me the question, any assignment in Google Earth Engine, no problem. So after the class, basically, it's 1 hours. Okay, so for the 1 hours, you can easily share the screen now if you have any problem. Okay, so you can easily share the screen if you have any problem regarding the assignment. You can easily share the screen. Then we discuss about the problem for assignment or any other problem. Okay, so after completing the 3 hours live session, then we just talk about the problem solving. Okay, in the problem solving class, you can easily share your own screen and show me your problem. Then we discuss about the solution. Okay, I hope there is no problem. So you try to find out the problem and ask me the next class. Okay, mainly 2 more inshallah. If you have any problem, so you before the class start, you simply open your problem in your browser. Okay, further easily share the screen and show me the problem. Okay. Okay, now any problem, you can ask me. Okay. Okay, thank you for joining. Okay, have a good night. See you in next day, inshallah. Okay, bye.
Thank you.
Okay, bye.